So here we are at problem 3D from the limits worksheet. We're asked to find the limit as x approaches -2 of this particular rational function. Now, if you went ahead and already tried direct evaluation, what you should have ended up with, if you did the math correctly, is that 0 over 0 indeterminate form. And unfortunately, that's not going to quite help us as we're trying to identify the correct limit. So one thing that we have to then fall back on is maybe factoring. Now, if we went ahead and factored the top, we have the limit as x approaches -2 of, and now we can factor out, looks like they all share a common x squared on top, so we can pull that out. And so you'd be left in with x squared plus 5x plus 6. Now the bottom, as you try and factor that, and that's not fully factored, but I only want to maybe do like one factor at a time. Now if you try factoring the bottom, this actually goes back to something in algebra where there's something called factor by grouping. And since both of these kind of terms share an x plus 1, you can literally factor or pull that out of both items. So we have x plus 1. And when you factor that x plus 1 out of, let's say, this first term, the only thing that you'd be left with is that x squared piece. Also, when you factor that x plus 1 out of the second term, looks like you're then just left with that minus 4. And so this is really known to be factor by grouping. You've literally pulled out this x plus 1 out of both elements. So now if I just go ahead and rewrite this limit, we end up with the limit as x approaches -2. And like I said, we're only going to focus on one factoring at a time. We can actually go ahead now and factor this top piece. So we end up with still that x squared, he's still there. But the two things that multiply to 6, that add to 5, well, that just comes out to be 2 and 3. So that would end up coming out to factor out to be x plus 2 times x plus 3. On the bottom, we still have our x plus 1 that we pulled out. And we can go ahead now and factor this x squared minus 4. Hopefully you can see that that is the difference of two perfect squares. So that just comes out to be x plus 2 times x minus 2. And from here, we can see that, hey, these x plus 2s, those match. One's on top, one's on bottom. We can cross those out. So we end up then with the limit as x approaches -2 of x squared times x plus 3 on top, all over x plus 1 times x minus 2. Now if we go ahead and try that direct evaluation by substituting in -2, let's see what we end up with. We have -2 squared times -2 plus 3 all over -2 plus 1 times -2 minus 2. So it looks like on top we end up with -2 squared, that's just 4, times -2 plus 3 just gives us +1. On the bottom, looks like we end up with -2 plus 1 in this first set of parentheses, so that just comes out to be -1. And then for the second set of parentheses, -2 minus 2 just gives us -4. So 4 times 1 on top just gives us +4. On the bottom, we end up with -1 times -4. That just gives us +4. So 4 divided by 4 just gives us that limit of 1. So that would be now our correct final solution, or limit. And again, that is problem 3D.